What's up, guys? My name is Cornelius Robinson, and this is Overshoot. Today, I'm designing a PCB for an LED acrylic name tag. So, let's get into it. This project is for someone in the Flux community, so I'm choosing parts that are not too difficult to solder. I'm starting out by looking for LEDs. He wants red and blue for a cool gradient look. Initially, I chose some low power LEDs because I needed 10 of them to last several hours on a single battery charge. However, I ended up going back to 20 milliamp LEDs because I was worried about the brightness. This part didn't have a footprint, so I decided to make one from scratch. I'll go into that process a little bit later. Next, I picked out a USB-C port for charging the battery. I found this power-only version, which was less expensive and would be easier to solder. Fortunately, it had a footprint and 3D model, so I added those to the assets. In order to actually use those assets, we need to go into the PCB tab, select Footprint, and add the Asset Object-Specific rule. The same applies for the 3D model. It looks like it's not oriented properly though. Not a big deal. We just need to add a rotation on the x-axis and set that to 90 degrees. That looks pretty good. The last thing I need to do is fix the mounting holes. If we don't, there won't be a pad to solder to. So let's add an object-specific rule to change it from a hole to a pad with a hole. Looking at the datasheet, the hole size needs to be 0.5 millimeters by 1.2 millimeters. We don't have to change all 4 of them individually though. We can simply copy and paste only the layout rules. I also spent some time looking through various types of batteries, and I think lithium ion or polymer is the way to go. Unfortunately, some of my recordings got corrupted, so we'll just skip ahead a little bit. Essentially, I found a battery management controller. It has an internal FET, so it will cut off the power to avoid over discharging the battery. I spent a lot of time reading through the datasheet so I understood how it worked. For example, the value of R3 determines how quickly the battery will charge. Currently it's set to about 500 milliamps. Next, I started on the LED circuit. These generic resistors are incredibly useful. I can set the value now and find an actual part later. The battery controller has a couple of outputs for status LEDs. Instead of adding more LEDs to the circuit, I'm just going to use the existing ones. I'm also using a D-type flip-flop to control the power as well as automatically turn off the LEDs when charging the battery. I'll just download the schematic symbol, footprint, and 3D model. Again, I just need to import the part and assign the assets like before. Oh no, looks like the footprint isn't going to work here. I'll just need to make it from scratch. Okay, when that's done, I can just pull it into our project and start wiring it up. The battery management controller has a dedicated input for turning off the system power, so that's where the output of the flip-flop goes. Looking at the datasheet, I'm realizing that the reset pin is active low, so I need an inverter to pull the output of the flip-flop low when charging the battery. Oops, this actually needs to be connected to the battery, not VCC. Next, I can place a debounce circuit for a push button. I also realized that this circuit wasn't going to work. So I added a couple of P-channel MOSFETs to disconnect the two status LEDs from ground when the battery is charging. Now that most of the schematic is done, I'm going through and finding actual part numbers for all of the generic resistors and capacitors I used. It's really just as easy as filling in the manufacturer name, part number, and other information you might want. Finally, we can start on the PCB. I'm starting off with setting the board size. Next, I'll work on the LED placement, since they're among the most important. Since I want all of them in a line across the bottom of the board, I can set a global rule. Selecting all of the LEDs can be done by using the part type property. As you can see, we have 10 parts selected. Then all we need to do is set the Y position, and the LEDs will all be aligned horizontally. To space them all evenly, I simply used the X position rule for each one. Then I could start placing the rest of the components where they needed to be. I reference the schematic quite often because I want to keep certain components close together. For example, decoupling capacitors act like a mini battery for an IC in case they suddenly need a little more current. It's important to keep these capacitors close, otherwise you could run into brownout conditions. It's not really a big concern with this board, but it's still a good practice. You might notice I'm not connecting the ground to anything but the bottom side of the board. That's because any extra space will be filled by a ground plane. I did run into an issue where the 5-volt rail from the USB port didn't seem to be connected in the PCB for some reason. So I decided to manually connect them together. With the battery management IC, the bottom vias are supposed to be connected to the ground plane, but right now they're not. Instead, I'm just going to make a wide trace to fill the gaps. It should still export the Gerber files correctly. This is starting to look pretty good. One last thing I'm going to do is add a couple of terminals, which will be pads for soldering the battery leads. I just need to label them and make the pads much larger. We can also look at the 3D view to get an idea of what it will look like. I think this is pretty much ready for export. I'll give you guys an update once the PCB is made. Like I mentioned towards the beginning of the video, this was requested in the Flux community. To get access, you can sign up on the main page by clicking on Community. Contact me in the community if you'd like me to design a board for you. Also, let me know what you guys think about this project. Do you want to see more videos like this, or would you rather I focus more on shorter tutorials? Let me know in the comments, and I'll see you in the next one.